Hello friends, in this video we will discuss some MCQs on biostratigraphy and the level of the question will be from easy to hard. Some question will be easier, some will be medium and some will be higher level. So we will start from the first question. So first question is, what is biostratigraphy primarily used for? Uh, I will take the pointer. Uh, Measuring the chemical composition of the rock, that is false, and dating and correlating sedimentary layers using fossil, analyzing the crystal structure of igneous rock, determining the magnetic properties of the minerals. So the question, the option B will be the correct answer. Dating and correlating the sedimentary layers using the fossils. So this is the primary purpose of biostratigraphy, what I told yesterday. Then in next question is, which characteristic makes a fossil species an index fossil? First one option is short geologic range and limited geographic distribution. Long geologic range and limited geographic distribution, short geologic range and wide geographic distribution, and long geologic range and wide geographic distribution. So this is a very common question. I think all the geology students know this question. This is short geologic range but wide geographic distribution. Option C is the correct answer. Which is a biozone in biostratigraphy? Option A layer of shady igneous rock with distinct cooling characteristics. Option B is a time interval defined by the occurrence of specific species, and option C is a body of rock defined by a mineral content, its mineral content, or D geographic region with similar climatic patterns. As we know, biozone is the fundamental unit of biostratigraphy that is defined by some specific fossils. So biozone is a time interval defined by occurrence of specific fossils. Option B is the correct answer. Which is the primary defining characteristic of biostratigraphic unit? A physical lithology and mineralogical composition of the rock layer, the absolute age determined through radiometric dating of isotopes, magnetic polarity signatures recorded within the sediment, and the presence of fossil content within the rock strata. So what defines the characteristic of biostratigraphic unit? Here option D is the correct answer. The presence of the fossil content within the rock strata, because magnetic, that is very different, and absolute age determination, that is also different. Mineralogical and lithological composition also different. Then question 5, which principles state that fossil organisms succeed one another in a definite and recognizable order? There are four options: principle of original horizontality, principle of cross-cutting relationship, principle of funnel succession, principle of superposition. Here correct answer is principle of funnel succession. Principle of funnel succession what states, with evolution, the older strata consist of the ancient forms and the younger strata consist of the recent forms, that more advanced forms. So what the question is asking, like, which principle state that fossil organisms succeed one another in a definite recognizable order? Like, definite order means the ancient, what is the ancient form and the advanced form, that is they are like saying these are or some orders. What is the principle of original horizontality? uh, when sediments get deposited within the basin, we can presume that the suppose the basin, we can presume suppose we presume that the basin surface is a horizontal layer. So how this sediments will spread across the basin? These sediments will spread across the basin like a mat. So this is a mat like in a horizontally. So this is the principle of horizontality. Then principle of cross-cutting relationship, I already knows the In this principle, this is the strata. This is the suppose this is the cross cutting magmatic body or like that. So in this case, the strata will be older and the magmatic body will be younger. This is the principle, and principle of superposition is the oldest this strata that will be that will be in the lower part, that is the older one, and the surface, that is top part of the strata are the younger one. This is the principle of superposition. Then, which group of organisms is commonly used in biostratigraphic study of Mesozoic marine rocks? So, this is very common question. So, by ammonites are the real invertebrates that used in biostratigraphic study of Mesozoic marine rocks. Similarly, trilobites in lower Paleozoic, and corals in some recent environment, corals are very important, and dinosaurs are not used in biostratigraphy. Then question number 7, what does FAD stand for in biostratigraphy? Option A, final age determination, fossil abundance datum, fossil analysis datum, fast appearance datum. So here I already told what is FAD and LAD. So FAD is fast appearance datum. These are wrong options. So let's go to the next question. Which type of fossil particularly useful for biostratigraphy in petroleum exploration due to their abundance in marine sediments? Option is vertebrate fossils, plant macrofossils, and dinosaur tracks. So as we know, the marine floor is abundance in microfossils. So microfossils is the correct option. So option C is the correct option. Microfossils are useful in biostratigraphy in petroleum exploration in marine sediments. Then next question is, what is the main limitation of biostratigraphy compared to radiometric dating? So option A is biostratigraphy cannot be applied to sedimentary rocks. So this is obviously biostratigraphy is applied to the sedimentary rocks. This is the wrong answer, wrong option. Then biostratigraphy only works in terrestrial environments. This is also wrong answer, because most of the biostratigraphy are established on marine sediments. Biostratigraphy provides relative edges rather than absolute edges. This is the correct answer. So biostratigraphy provides the relative edge. So we can say here, suppose in Cretaceous we are getting this fossil in India, and in USA we are also same fossil we are getting. So we can age the rock as Cretaceous. This is the relative age. But in case of radiometric dating, we can get the absolute age in numbers. That will be the more that is the more correct age. So this is the limitation of biostratigraphy. And option D is biostratigraphy requires expensive laboratory equipments. That is also wrong. That doesn't requires expensive lab equipments. Only microscope required for the biostratigraphy. And next question, which term describes fossil that lived in a narrow range environmental condition are useful for interpreting ancient environments? Guide fossil, facies fossils, index fossils, and trace fossils. Here the correct answer is index fossil. Also index fossil and guide fossil are same, but more correctly we can say this index fossil is the correct answer. Facies fossil is not a term that I have heard till now. And trace fossils are the trails and tracks that we observed in sediments where original fossil material was absent. Then question 11, what phenomena can cause the same biostratigraphic event to occur at different times in different locations? Catastrophism, synchronity, uniformitism, diachronity. So here the correct answer is diachronity, because catastrophism is a event that suddenly happens and that disrupts lot of things, and that changes lot of things in the earth history. And uniformitism is slow progressive changes, and diachronity is the correct answer here. Then question number 12. Why might a biozone boundary defined by last appearance datum LAD be less reliable than one defined by the first appearance datum in the succession? As I have already told, in case of last appearance datum, the geologist sometimes get confused because some erosional or unconformity took place, so that some geologists took it as what this is a extinction event, or that is the last appearance of the species. So that is not the actual extinction, that is not the actual last appearance of this species. So last appearance is not a reliable, not reliable than first appearance. So what is the cause? So option A is LADs may be more affected by erosion, non-deposition and ecological retreats, causing occurrence to appear earlier than true extinction. This is the correct answer. So we cannot LADs are morely affected by erosion, non-deposition and ecological retreat, causing last occurrence to appear earlier than extinction, true extinction. Then question number 13. uh, when developing when developing a high resolution quantitative biozonation for an oil field, which practice would most improve the robustness of the resulting zonation? So here options are: using only the key index fossil that appears in all wells to simplify the zonation, defining zones solely on lithologic changes, and then assigning fossils to those zones afterward, integrating multiple fossil groups and calibrating their zones against independent markers such as wireline logs and seismic reflector, and ignoring sample with low fossil count, and avoid dealing with the statistical uncertainty. So here we have to first understand the question. What is they are saying? In case of high resolution quantitative biozonation, which practice give more robust result? So for most robust result, we have to integrate some fossil groups with the independent markers such as oil line logs and seismic reflectors, that will give more like robust result. So we can avoid all the other options. So here option C is the correct answer. And then question number 14: which situation best demonstrates a limitation of biostratigraphy due to diachronous fossil ranges? Option A: species appears to exactly the same stratigraphic level in multiple basins regardless of phases. A global abrupt extinction horizon is identified for a planktonic group coinciding with major volcanic ash layer. A taxon shows short oil constant stratigraphic range in all studied sections. Option D: the first appearance of benthic foraminifera occurs earlier in shallow phases, later in deeper basinal phases. So here what the question is asking: what is the limitation of biostratigraphy due to diachronous fossil range? So the question is asking what is the limitation of diachronous fossil range. So here the limitation will be the first appearance of, suppose the first appearance of benthic foramina occur in shallow phases, later in deeper basinal phases. So suppose in one place the benthic foraminifera occur in shallow shale phases, then later in deeper basinal phases. So we cannot correlate these two succession means easily, or we cannot correlate these two succession in a with a stronger convention. So in this case, what the diachronous units, suppose this is one unit, this is one unit, this is deposited in shallow, this is deposited in deep. So we cannot correlate it in great confidence. So this is the correct answer. The first appearance of benthic foraminifera, this is one example, occurs earlier in shallow shale basin and later in deeper basinal phases. Then question number 15. A quantitative biostratigraphic study uses occurrence data for multiple planktonic species and applies clustering algorithm to identify statistically extinct assemblages. What is the main advantage of this approach compared to visually defined assemblage zone? So what we do in quantitative biostratigraphy, for example, in planktonic species, clustering method used to apply. Clustering method, we use some softwares like PAST and other softwares to cluster the different samples or cluster the different species, so that we can get a very more robust result. Because in some cases visually one person can make mistakes, but so in software or in case of statistical analysis, the chances of mistake will be very low. So what are the options? It yields assemblage definition that are more objective and reproducible across different investigations. It produces assemblage that are independent of sample size and preservation quality. It guarantees that identified assemblage correspond exactly to the global time slices. And option D is it completely eliminates environmental influences and assemblage composition. Here option A is the correct answer. It yields assemblage definition that is more objective. What I told, that some more robust result will get. So the definition more objective and reproducible across different investigation. Suppose one biostatic stratigrapher or paleontologist established one biostratigraphic zone. This biostratigraphic zone he established, suppose A and B biostratigraphic zone, on the basis of his study. But that person can also, there is as a human being there is some suppose in counting or something happened and there is some mistake, but in this case the reproducibility will be more. So suppose another paleontologist came, suppose in case of quantitative biostratigraphy, by utilizing the statistical methods, one paleontologist established one biostratigraphic zone using cluster analysis. Suppose another paleontologist came, he also tried to establish biostratigraphy in the same horizon. In case of statistical or quantitative biostratigraphy, that cannot be different, that will be same. But in case of manual method like visual method, it may differ. So this is the advantage of the quantitative biostratigraphy. Then option question number 16 is, which of the following best illustrates a limitation of biostratigraphy correlation due to phase dependence? Option A is, using the same coordinate biozone scheme across a range of deep water and shallow water carbonate phases where coordinates are abundant. Application of oil calibrated ammonite zonation across multiple basins with similar depositional environment. Inability to co-regulate coastal sandstones with offshore shale because of key marine planktonic index fossils are absent in the sandstones. And correlation of two pelagic limestone sections using globally distributed planktonic foraminiferal biozone schemes. So here what he told, what is the limitation of biostratigraphy in correlation due to phase difference? So what we can, suppose phase difference means what it told. Suppose here one, here planktonic foraminiferas deposited in very soft, very fine grained sediments that give rise to shell, and this planktonic foraminiferous get preserved in that shell. And here also at the same time planktonic foraminifera exists, and they also get deposited in coarse grain sand kind of sediment. So it gives rise to sandstone. As we know, in sandstones, due to high energy condition, there are several scenarios like high energy condition and due to diagenesis of sandstone and due to lithification of sandstone, due to high energy condition, that as you know planktonic foraminiferas are made up of very soft and very filthy material, calcium carbonate, so that will get destroyed immediately. So in that condition, in sandstone we will not get the planktonic foraminifera. So although they are deposited in the same kind of environment and same species exist here and here, but we are not getting this. So here this is the correct answer will be C. Inability to correlate coastal sandstone with offshore shale because of key marine planktonic index fossil are absent in the sandstone. This is the limitation. Then question number 17. In quantitative biostratigraphy, what is the main advantage of using quantitative fast and last occurrence rather than relying on single observed horizons? Option A, it eliminates the need to sample multiple sections because one section becomes sufficient, and it allows estimation of true organization and extinction levels by accounting for incomplete sampling and reworking. Option C, it removes the influence of species control on the fossil distribution completely. And option D, it guarantees exact correlation at bed by bed level across all sections. So what the question is asking, we have to first understand. In quantitative biostratigraphy, what is the main advantage using the fast and last occurrence data rather than relying on single observed horizon? So here the true answer will be, it allows estimation of true origination and extinction levels by accounting the for incomplete sampling and reworking. What happens in case of biostratigraphic, when one paleontologist try to establish a biostratigraphy, uh, there sometimes there will be mistake. Sometimes suppose here one bed is there, here one bed is there, and the fossil we are getting from here to here, this is the range. But the paleontologist studied from here to here this section. What he thinks here this is the true range, and he established the biostratigraphic zonation. But after some time this fossil reappears, and this because of some environmental condition or phasage control, this fossil absence in this mid horizon. But in case of quantitative biostratigraphy, we have to take all the data, we have to take statistical software to reconstruct the stratigraphy. So uh, in this case, the software will consider this one and this one, so he will give more result, more robust result. So the extinction levels by levels of accounting and incomplete sample and reworking, this will be the correct answer B. It allows the estimation of true or origination and extinction. Like in quantitative biostratigraphy, it gives the true origination and true extinction. Uh, Question number 18. What is the primary difference between interval biogen and assemblage biogen? Interval biogens are based on lithological changes, whereas assemblage biogens are based on fossil color changes. That is wrong. And interval biogens always use quantitative methods. That is also wrong. Interval biogens are commonly used in terrestrial setting. That is also wrong. Interval biogens are defined by ranges between two bioevents, whereas assemblage biogens are defined by reoccurring of set of taxa. This is the correct answer. And question number 19. Which type of biozone is defined by the maximum relative abundance of the specific taxon rather than total range? This is the abundance zone. And what I already told, this is suppose in a piece of rock, this is different status. Here in this piece of rock there is abundance of this one species. So this is the abundance zone. And taxon range zone I have already told, this based on the range of one taxon. Concurrent zone overlapping of two different taxon, this overlapping part is the concurrent zone. And assembly zone, there is a overlapping of two or three or more than three taxa. So the part of overlapping is the assemblage zone. And then question number 20, a taxon range zone is defined by which two boundaries overlapping between ranges of two unrelated taxa, the LAD of taxon A and the FAD of taxon A, the FAD of taxon A and LAD of taxon B, and the first appearance and last appearance of the single taxon. This is the correct answer, because here some confusing options are there, like question B, like LAD of taxon A and FAD of taxon A. First, in a horizon, the LAD cannot come first, and FAD will come, then LAD will come. So this is the wrong answer. Then FAD of taxon A and FAD of taxon B, like he is saying first appearance of taxon A and first appearance of taxon B. This is also wrong. So first appearance and last appearance single taxon, like FAD of taxon A and FAD of taxon B. That if option will be like that, that will be the correct answer. Here, this is the correct answer. Option D. Question number 21. How does a concurrent range zone differ from taxon range zone? Option A, it requires the presence of at least 10 different fossil species. This is wrong. It defined by the overlapping of two taxa with a different stratigraphic range. So this is the correct answer, and it is based solely on total range of the most common fossil range. That is also wrong, and it only uses fossil that are found in single geographic location. That is also wrong. So as we told, concurrent range zone is overlapping of two taxa. Like I have already told, suppose this is the range of one taxa and this is the one of another taxa. This overlapping part only. This is the concurrent range zone. A B concurrent range zone. Suppose this is fossil A, this is fossil B. A B concurrent range zone. So here this is the correct answer, option B. Then which biozone represents a specific segment of an evolving lineage? As I have already told, one option was there, that is lineage or consecutive range zone. This zone represents a specific segment of evolving lineage. I have already explained this acme zone, abundance zone and partial range zone. Here the correct answer is lineage zone. Then why is evolution considered the fundamental basis of biostratigraphy? Option A, because it explains how rocks are physically folded and faulted. This is wrong. And because it allows scientists to predict exactly which species will evolve next. That is also wrong. Because it proves all organisms lived for the same amount of time. This is also wrong, because biological changes are irreversible and occur in definite order. This is the correct answer. Because what biological changes, suppose a foraminifera coiling, here coiling is somewhere like somewhere this is coil clockwise coiling, and here anti-clockwise. That cannot be reversed. So we can differentiate this different two strata, like biostratigraphically using this foraminifera, and this occur in a definite order. Like here coiling is clockwise, this is anti-clockwise, another coiling will be different. So this is the correct answer, option D. Then next question is 24. According to the remaining conventions, how should a biostratigraphic unit be named? By the name of the geologist who first discovered the fossils. That is wrong. Means we can name the species or taxa according to the name of the geologist who discovered the fossil, but biostratigraphic unit cannot be named after the name of the geologist. Combining the name of one or two characteristic fossils with unique term, and using numerical based order of discovery, using the name of the geographic location. That is also wrong. Fossil species or taxa can be named according to geographic location where it was found first. So this is the correct answer, option B, combining the name of one or two characteristic fossil with a unique term. For example, one taxon range on one fossil A is there, and this is the range of fossil A. So A taxon range on. For concurrent range on, there is two fossils are there. This part, fossil A and B. So here A B concurrent range on. This is the this is naming of the fossils. Then question number 25. Which group of organisms typically makes the last index fossils for global correlation? Rare for species that only existed in a single basin, benthonic organisms that are restricted to specific environments, organisms which are very slow evolutionary rates, and planktonic organisms with wide geographic dispersal. So, as we know, the question is asking, which group of organisms typically makes the best index fossil for global correlation? The planktonic fossils are that free swimming swimmers, so they can swim from here to there. So for global correlation, and because of this free swimming nature, the planktonic fossils can planktonic species can travel from one part of globe to another part. So planktonic organisms are wide with wide geographic dispersal are very best index fossil for global correlation. Then question number 26 is, it is the last question. A partial range zone is an interval zone defined by boundaries between the FAD of one taxon and LAD of another unrelated taxon. Question option B, the total range of single species across two different continents, the absolute maximum abundance and absolute minimum abundance of a taxon, two different lithological changes in the column. So here the option A is the correct answer. FAD of one taxon and LAD of another taxon. Like I have already told, suppose this is the rock strata. Here the this is the range of a fossil A, this is the range of the fossil B. So here this is the LAD and this is the FAD. Similarly here the FAD and here the LAD. So this is one interval zone. In this interval zone, this is one interval zone. This in this interval zone, the LAD of fossil A and FAD of fossil B is considered. So here option A is the correct answer. This is the last question. Thank you.